Hi everyone, welcome to this YouTube tutorial. In this section, I'm going to briefly uh, look about the molecular formulas because this is a very crucial topic to chemistry. From the previous videos that I've been posting, this is where chemistry begins to get a bit complicated. So we need maximum attention with this topic because it's the basis of what is going to follow in most of the topics. So to begin with the molecular formula, our objective today will be looking at the molecular formula and what it means, and allotrope, molecular models, and then empirical formula. So from this, that's where we build the rest of everything that we are going to discuss. So the molecular formula shows what the exact atoms of each element in their smallest unit. So for example, if I have a molecular structure of, let me say, table salt, sodium chloride, which is sodium chloride. So the molecular formula of sodium chloride is NaCl. It is showing me that in this formula you have an atom of sodium and an atom of chlorine. In another example is water, H2O. I have two atoms of hydrogen and one atom of oxygen. So a molecular formula shows you exactly what is in the compound to the smallest unit. So we have one oxygen, two chlorines, one oxygen, two hydrogens, one chlorine, and one sodium. So to go further to the next objective, the allotrope. So an allotrope is one or two or more distinctive forms of an element, and this property is very common with carbon. So we shall see this that carbon exists as graphite and also as diamond. So an element that exists in more than one form is called an allotrope, and it's very common with carbon. Then for the next objective are the molecular models. So I have a few molecular models in my hands, and let me begin with the simplest molecular model. The white, color white represents hydrogen. Blue is for nitrogen, and red is for oxygen, and black is for carbon. So in my hands here, I have a simplest molecule, which is hydrogen gas, like in the previous chapter. Sorry, the hydrogen gas. So hydrogen is diatomic and has a bond joining two atoms together, so it exists as a molecule. So it's a diatomic molecule. So and also I have here methane, which is carbon with four chlorines, with four hydrogens bonded on it. And also I have ammonia. The blue is nitrogen with three hydrogens on it. I have the simplest molecule, water, H2O. And lastly, I have dinitrogen tetrahydrogen, two nitrogens and four hydrogens. So the reason why I brought these models is for this last example of the empirical formula. So an empirical formula tells us which elements are present in their simplest ratios of their atoms, whereas the molecular formula tells us the molecular formula will tell us what that is, but the empirical formula will tell us what ratio are they in. Like for example, sodium exists as both a molecular formula and an empirical formula because everything is 1-to-1. Whereas if I have a molecule of dinitrogen tetrahydrogen, which is two nitrogens and four hydrogens, so the empirical formula of this will be one nitrogen and two hydrogens. So this is the empirical formula. So when I multiply this by 2, I'll get back this. So an empirical formula tells us in which ratio are the elements in the compound existing. So if I look at methane, I will have a ratio of 1 carbon to 4 hydrogen. Still, this methane still exists as a molecular formula and also an empirical formula, because that is its simplest ratio. Whereas for this dinitrogen tetrahydrogen, you see that there is a ratio of 2. So an empirical formula is the simplest. It tells us what ratio are the elements in the compound existing as, whereas in the molecular formula it shows us all the details of how many of nitrogen you have and how many of hydrogen you have and how are they bonded. So this is the brief chapter for the next chapter that we are going to look at, formulas and ionic compound. So in the next chapter we shall be looking more about the empirical and molecular formula, because if you didn't have the brief history about it, it will be very hard for you to understand it. So catch you in the next chapter with more details in the formula of ionic compounds. Bye for now.